Hello folks, we come to the new exercise 9.4, and here the nature of the question is quite different. What they do is they will give us an expression and they ask us to find out the sum to n terms for such a thing. They would have given you an expression like this, we have to find out the sum to n terms. So what we will be doing is we will be finding a general term ak, and once we add up all the ai's we will be able to get sn. That idea we will use and we will try to find out the problems. I hope it's clear to you that if we know a general ak, that means you can predict all the terms a1, a2, like that you can predict all the terms till an. Suppose if we add a1 plus a2 plus a3 and an, we will be able to get sn. So this is the idea that we are going to use. First we will get a general term ak, then we will add up all the ai's to get the sum. So let's do this. So here first our idea is to get a general term. How can we get a general term? Let's look at the relation. This is the first term. First term is 1 into 2. This is a2, this is a1, this is a2, this is a3. So a1 is 1 into 2, a2 is 2 into 3. So when it was 1 here, it is 1 into 2. When it is 2 here, it is 2 into 3. When it is 3 here, it is 3 into 4. So when it is k, it will be k into k plus 1. Whether it is convinced to you, just check. Yes, it is like that. So therefore writing this is maybe if you open it up, it will be k squared plus k. So sum to n terms is summation ak, k taking values from 1 to n. Yeah, you add up a1 plus a2 plus a3 plus a4 plus and so on an. And shortcut in symbol form, we write it like this: k taking values from 1 to n, you add up all the ai's or ak's, you get the sn. So how do we write this now? K equal to 1 to n, ak we know is k squared plus k. We have learned that the summation symbol they can distribute, so you can have it like this. Right. Now all this is nothing new to you. We have learnt it in the binomial and we have learnt it otherwise also, that 1 plus 2 plus 3 and so on n, which can be also called as summation k, k taking values from 1 to n. You are adding up 1, 2, 3 means k first, when it is 1 it is 1, then when k is 2 it's 2, when so on. That by formula we have learned is n into n plus 1 by 2. So also 1 squared plus 2 squared and so on n squared. When we write it, when we represent it, it is probably summation k squared, k taking values 1 to n by formula is n squared, n times n plus 1 into 2n plus 1 by 6. Same way, 1 cube plus 2 cube and so on n cube by representation is summation k cube, k taking values from 1 to n. By notation it is n squared into n plus 1 squared by 4. So we'll use this as and when required. Same thing is coming here. We know that is summation k taking values k squared, so that is n into n plus 1 into 2n plus 1 times by 6, and this summation k we know is n into n plus 1 by 2. So what we will do, we have things common here, n into n plus 1, n into n plus 1 and 2, but partially 2 can be taken up common. So n into n plus 1 by 2, let's take common. So in the first bracket 2n plus 1 by 3 remains, and in the second bracket only 1 remains. Then we can equalize it into 3 into 3. So it comes to n into n plus 1 by 2. This is 2n plus 3 plus 1, 4 by 3, or rather it is n into n plus 1 by 2 into 3, and 2 can be taken common, n plus 2, cancel. So you get n into n plus 1 into n plus 2 by 3 as a sum. This is the required sum, and this is how we do it, right? Okay, and the second problem as it is given on the board, it's just one step ahead, same, but here there were 2 terms, here there are 3 terms. So I think it will be easy for us to predict. One more term is there, that's all. So maybe it's easy for us to predict here. ak will be k is there, k plus 1 is there, then k plus 2 is also there. Only thing, opening up and all that, a little more laborious, that's all. So let's open this up. This we know is k squared plus k times k plus 2. So let's open it up. K cube plus 2k squared plus k squared plus 2k. So it is like k cube plus 3k squared plus 2k. Now what is Sn? It is summation ak, k taking values from 1 to n. That means it is summation k cube plus 3k squared plus 2k. So it is summation k cube plus 3 times summation k squared 2 times summation k by formula n squared into n plus 1 squared by 4, by formula n into n plus 1 into 2n plus 1 by 6, by formula n into n plus 1 by 2. Right, as we did before, you can take whatever things you want common, you can take it out. Like I think n into n plus 1 by 2 is common everywhere. In the first term, therefore 1n into n plus 1 by 2 is left. In the second, you could have it cut. So in the second you would have only 2n plus 1 left. Then in the third also, if the 2 is there, maybe, yeah. So it will be 2n plus 3. So you would have n into n plus 1 by 2, and then this you have to equalize by 2. So overall equalized by 2, you have n squared plus n, and here now this is 2n plus 3, but equalized by 2 it will be 4n and 6. So this will come to n into n plus 1 times by 4 in the denominator, and n squared plus 5n plus 6. Now this actually we can split middle term, n squared plus 5n plus 6. 5 could be 3 and 2, so n squared plus 3n plus 2n plus 6, like that. So this will split into n plus 3 into n plus 2. So you could have this finally as n into n plus 1 into n plus 2 into n plus 3 by 4. Just one step ahead, just check n into n plus 1, n plus 2 by 3, and here n into n plus 1, n plus 2, that n plus 3 term is extra and 3 is replaced by 4, almost like that way. Okay, next we go to the next problem, 3 into 1 squared, 5 into 2 squared, 7 into 3 squared, and so on. So let's predict what is AK. This is A1, this is A2, this is A3. When it was 1, the 1 is there here. So we can always say that there is a k squared, right? In all the 3 terms you can see it. And then there is, in one case there is 3, in one case there is 5, in one case there is 7. What is the relation? Is it 3 times? It is not 3 times. Is it 2 times? No. Yes, but it is 2 times plus 1. Yes, in all cases it is 2 times plus 1. So maybe you can take it like that, 2k plus 1. Wherever, whatever k comes, plus 1 will be, in the first case it is 2 plus 1, 3. In the second case it is 4 plus 1, 5. And next case it is 6 plus 1, 7, which are all 2k's. So that's how it is. When we open this up, it will come to 2k cube plus k squared. So your Sn will be summation ak, k will take values from 1 to n, which means it is summation k taking values from 1 to n to k cube plus k squared. So take it to k cube and k squared. So 2 k cube means it is n into n plus 1 squares by 4 plus n into n plus 1 into 2n plus 1 by 6. Take common, 2 into n into n plus 1 by 2. So n into n plus 1 by 2 is left, and here 2n plus 1 by 3 is left. You could have it equalized, n into n plus 1, you could have it equalized, this into 3 and this into 2. So you would have 3n squared plus 3n, and here it would be 4n plus 2 by 6. So it's like yeah, so it's like n into n plus 1 minute, yeah. Oh, something is not so okay here. Okay, 2 is not overall common. I would like to do this part once again. Lots of this misconceptions. The idea is the same, but this 2 has come unnecessarily. 2 is only applicable to this, and I don't know, somehow it's not written properly. It is n into n plus 1 the whole squared by 4, and this is by 4, and this is n into n plus 1 by into 2n plus 1 by 6. So that's just 2. So we are taking n into n plus 1 by 2 common. So here we are left with n into n plus 1, and here we are having 2n plus 1 by 3 left. So like that makes us equalize into 3 into 3. So n into n plus 1 by 2, and this becomes therefore 3n squared plus 3n. When we have this 3n open up, 3n we are opening up, and this is like 2n plus 1 whole by 3. So that's like n into n plus 1 by 6 into 3n squared plus 5n plus 1. That's your answer. Right, that's our problem 1, 2 and 3. With similar problems we come in the next part. Thank you.